In the Nmap lectures, we have seen no port scan, also known as ping scan, different ways of scanning ports, syn scan, also known as half-open scanning, TCP scan, also known as TCP connect scan, UDP scan, service and version detection, and operating system detection. Now let's deep dive in Nmap. The Nmap scripting engine, or NSE, is one of Nmap's most powerful and flexible features. It allows users to write simple scripts to automate a wide variety of networking tasks. Now, those scripts are then executed in parallel with the speed and efficiency you would expect from Nmap. Users can rely on the growing and diverse set of scripts distributed with Nmap or write their own to meet custom needs. So I'll show you a couple of things here. Scripts are written in the embedded Lua programming language, version 5.3. NSE is activated with the S_C option, or script, if you wish to specify a custom set of scripts, and results are integrated into Nmap, normal, and XML output. The default place of Nmap embedded scripts is /user/share/nmap/scripts. NSE was designed to be versatile with the following tasks in mind. Network discovery. Now, this is the most powerful part of Nmap, right? Examples include looking up whois data based on the target domain, querying RIPE for the target IP to determine ownership, SNMP queries, and listing available SMB shares and services. More sophisticated version detection. The Nmap version detection system is able to recognize thousands of different services through its probe and regular expression signature-based matching system. But it cannot recognize everything. For example, identifying the Skype version 2 service requires 2 independent probes, which version detection isn't flexible enough to handle. Nmap could also recognize more SNMP services if it tried a few hundred different community names by brute force. But neither of these tasks are well suited to traditional Nmap version detection, but both are easily accomplished with NSE. Vulnerability detection. When a new vulnerability is discovered, you often want to scan your networks quickly to identify vulnerable systems before the bad guys do. While Nmap isn't a comprehensive vulnerability scanner, NSE is powerful enough to handle even demanding vulnerability checks. Remember when the Heartbleed bug affected hundreds of thousands of systems worldwide? Nmap's developers responded with the SSL Heartbleed detection script within, it was under 2 days. Backdoor detection. Many attackers and some automated worms leave backdoors to enable later entry. Some of these can be detected by Nmap's regular expression-based version detection, but more complex worms and backdoors require NSE's advanced capabilities to reliably detect them. Vulnerability exploitation. As a general scripting language, NSE can even be used to exploit vulnerabilities rather than just find them, but of course, it's not as powerful as exploit frameworks, such as Metasploit. Okay, so let's get to it. NSE is activated with the S_C option, or script, if you wish to specify a custom set of scripts. Script scanning is normally done in combination with a port scan because scripts may be run or not run depending on the port states found by the scan. You can use S_C to perform a script scan using the default set of scripts. It is equivalent to script equals default. Now, wait a second. Now, what is this default? Well, it is one of the categories of Nmap scripts. Let me show you. Nmap scripting engine, NSE scripts, define a list of categories that they belong to. So currently defined categories are auth, broadcast, brute, default, discovery, DOS, exploit, external, fuzzer, intrusive, malware, safe, version, and vuln. Category names are not case sensitive. So let's give you a little detail. Default scripts are the default set and are run when using the S_C rather than listing scripts with script. This category can also be specified explicitly like any other using script equals default. Auth scripts deal with authentication credentials, or coincidentally bypassing them, on the target system. Examples include Oracle enum users. Brute scripts use brute force attacks to guess authentication credentials of a remote server. Nmap contains scripts for brute forcing dozens of protocols, including HTTP, brute, Oracle brute, SNMP brute, etc. DOS scripts may cause a denial of service. Sometimes this is done to test vulnerability to a denial of service method, but more commonly, it's an undesired by necessary side effect of testing for a traditional vulnerability. These tests sometimes crash vulnerable services. Exploit scripts aim to actively exploit some vulnerability. Examples include HTTP shell shock. Now, scripts which weren't designed to crash services use large amounts of network bandwidth or other resources, or exploit security holes that are usually categorized as safe. Intrusive scripts are those that cannot be classified in the safe category because the risks are just too high that they're going to crash the target system, use up significant resources on the target host, such as bandwidth or CPU time, or otherwise be perceived as malicious by the target system administrators. Malware scripts test whether the target platform is infected by malware or backdoors. Version scripts are an extension to the version detection feature and cannot be selected explicitly. They're selected to run only if version detection, that's S_V, was requested. And vuln scripts check for specific known vulnerabilities and generally only report results if they're found. You can alternatively use script parameter to run a script scan using the comma-separated list of file names, script categories, and directories. Each element in the list may also be a Boolean expression describing a more complex set of scripts. For example, if you use script parameter using the default and safe expression, the scripts which are in both default and safe categories run. That makes sense. Script update DB option updates the script database found in script/script.db, which is used by Nmap to determine the available default scripts and categories. It's only necessary to update the database if you have added or removed NSE scripts from the default scripts directory, or if you have changed the categories of any script. This option is used by itself without arguments. Okay, so let's see some of these scripts and try to use them. Open a terminal screen in Kali. To find out the scripts, use the locate Linux command. Since the file extension of Nmap scripts are .nse, type locate *.nse and hit enter. It'll locate the files which end with .nse. This is where the Nmap scripts are located in Kali by default. Go to the folder using the cd command. I select the path and press the middle button of my mouse to copy and paste it and hit enter. Now let's look at the script.db file first, which is a script database used by Nmap. It's in this folder. I use less command to look at the content of the file. Every row contains a script file name and its categories. So now we can see the usage of Nmap scripts. I want to try SSH scripts on my Metasploitable VM. First, with the help of Linux grep command once again, I want to list the SSH script. Here are the scripts that have the SSH word in their names. To analyze the content of a script, I use less command. Now let's look at a file, for example, ssh hostkey.nse. The script file has a description, a usage section, and many more lines. I want to show you the category section of the script. In the less command, you can use a slash key to search a word. Press slash, type Kate, and hit enter. Here it found Kate in the word duplicate. This is not what we're looking for, so press the N key to find the next Kate word. Again, duplicate, press N once again, and we found the category section. Alternatively, you can use the script help Nmap parameter to get help about an Nmap script. Type Nmap, script, help, and then the script name. File extension is optional here. It's okay if you don't use the extension. Now here's the brief summary of the SSH host key script. Script name, a link to learn more about it, and the description of the script. Now look at the description of the SSH host key script. It shows the target SSH server's key fingerprint, and with high enough verbosity level, the public key itself. Now, let's run a few Nmap commands and use some scripts. Prepare the Nmap command, TCP SYNSCAN. Don't forget to define the port of your interest. First, I want to run the default SSH scripts using the C parameter. SSH host key is the default script for SSH service. And here are the target SSH server's key fingerprints. In the description of the script, we saw that if the verbosity level is high enough, the script will show the public key itself. To see it, I want to run the nmap command again, but this time I use the V to increase the verbosity level. Now we have the public keys as well as the fingerprints. Here is another example source of an Nmap script. In addition to the code part, which is to execute the job of the script, it includes some additional sections such as description, categories, usage, author, license type, etc. Instead of probing the script code to understand the details of an Nmap script, you can use script-help parameter of Nmap command. You will see the name, the categories, the link to deep search, and the description sections as the result of the script-help query. So you've heard me say it before, but I really need to emphasize the importance of the service and version detection once again in this Nmap scripting lecture. As you know, if you don't run the version detection, Nmap supposes that the default service is running on that port. In a script scan, Nmap supposes the default service is running on the port, so it runs the scripts as if they are suitable for that service. It's easy to see it in an Nmap query. Okay, open a terminal screen in Kali. I use netstat command to see the listening ports. As you see, SSH service is running, but it's not running on port 22. Instead, it's running on port 443, and as you know, 443 is the default port of the HTTPS service. So if I run a port scan from my Kali's port 443 without adding the version detection option, Nmap signs the port as running an HTTPS service. Now, if I add the SSH scripts in this query using script SSH asterisk, without the version detection, not any of the scripts run, because Nmap thinks that the service is HTTPS, not SSH, and does not run the SSH scripts. So I call the latest Nmap query and add version detection using the V this time. Look at that, SSH scripts are started. With the version detection option, Nmap finds that the service is SSH and not HTTPS. Very important. Okay, so SSH brute script takes a long time to run. We already got the point, so no need to wait for the results of the scripts. Here we have some scripts which are very helpful in penetration tests. The scripts that end with brute perform brute force password guessing against the named services. The scripts ending with info gets the information about the named services. DNS recursion checks if a DNS server allows queries for third-party names. DNS zone transfer requests a zone transfer, AXFR, from a DNS server. If the query is successful, all domains and domain types are returned along with common type-specific data, SOA, MX, NS, PTR, or A. HTTP Slow LoRa's check tests a web server for vulnerability to the Slow LoRa's DOS attack without actually launching a DOS attack. MS SQL Info attempts to determine configuration and version information for Microsoft SQL Server instances. MS SQL dump hashes dumps the password hashes from an MS SQL server in a format suitable for cracking by tools such as John the Ripper. NBStat attempts to retrieve the target's NetBIOS names and MAC address. By default, the script displays the name of the computer and the logged-in user. If the verbosity is turned up, it displays all the names the system thinks it owns. SMB enum users attempts to enumerate the users on a remote Windows system with as much information as possible. The goal of this script is to discover all user accounts that exist on a remote system. This can be helpful for administration by seeing who has an account on a server, or for penetration testing or network footprinting by determining which accounts exist on a system. SMB enum shares attempts to list shares. Finding open shares is useful to a penetration tester because there may be private files shared, or if it's writable, it could be a good place to drop a Trojan or to infect a file that's already there. Knowing where the share is could make those kinds of tests more useful, except that determining where the share is requires administrative privileges already. In a penetration test, you should try the pass the hash method to compromise systems, and the last 3 scripts will be very helpful for your pass the hash attacks. Here you see some useful brute force or dictionary attack scripts for FTP, databases such as MySQL, Oracle, or MS SQL, SNMP, Telnet, etc.,